Welcome friends to another episode. Today let us design a seeder. A seeder that can ease up the job of seeding smaller seeds like red gram, black gram, maybe lady's finger seeds at a faster pace than what we can do manually. Also, this will have facilitate us in having the proper distancing between the two seeds. We will be using locally available materials that are as cheap as is possible. The seeder can be divided to two parts. One, the vehicle that carries the seeder. The other, the part will be the one that will be dispersing seeds at equal interval. So for the seeding part, we will be using PVC and CPVC. For making the vehicle, we will be using steel and two big rubber tires from a small cycle and a single 3-inch tire so that it will be stable. Let us move to the design part. Materials used: 1.2 centimeter wide metal rod of around 10 inches length, a small piece of 1-inch angler, another small piece of 1-inch plate will be needed. We need around 4 inch of this plate, 1-inch plate, and 8 inch of angler. And this lengths are not actually a standard. It depends on how you make it. It may be little less or maybe little more. It depends again on your kind of way of preparation. Also, you'll need a connector bolt of around a meter length with around 7 millimeter in diameter. You'll need these nuts and bolts around 10. Front wheels are connected using the connector bolt, a piece of connector bolt around 3 to 4 inches, and this connector bolt is welded to the 1.4 mm rod, and at the back side you are having a single tire around 3 inches, again that is bolted into two nuts that are welded to the main frame. So that forms the framework of the machine. Now this is the handle used. You can use any material. This is steel of around 0.5 inches width, and to make the handles adjustable I am using a connector nut welded out here on the bottom side, and two connector bolts are welded here. Onto the handle again two nuts are welded, and a small piece of connector bolt is welded, and two 4 mm washers are welded, so that the whole unit acts like a hinge out here. Now this handle can be connected to the hinged bolt by removing these two nuts out here. Like this, and by adjusting these nuts you can vary the height of this rod. You can select your comfortable position. At your comfortable position you can further lock it using two nuts. So this forms basically the framework of our seeding machine. So once you lock this, your handle gets locked there. This is the actuator mechanism that creates a rotational movement needed to activate a cylinder that is installed within this cylinder to systematically drop down the seed at correct intervals. Now the chain I am using is a timing chain of some bike, like maybe Platina or Hero Honda, I am not sure. And these two wheels also come from the same vehicle. So here the chain is tied like this, and this chain is attached to the wheel using 4 screws, and these screws are attached using plate washers that you are seeing here. It's 2 plate washers on both the sides, and the screws are drilled through the plate washers. So this is the external mechanism. Now one more thing that I wanted to say is regarding the angler that we used. So since this is chain driven, there is a need to adjust the chain tension. So for that, what I have done is onto an angler I have welded a small steel section here, put 2 washers out here, and this cylinder is bolted to the washer. Now here comes the height adjustment part. So we had this angler out here. So onto the angler I am placing is 1-inch steel like this, and I am welding and covering it here and inserting a bolt here. So that's what you are seeing. This long nut is connected to the angler. I'll show you the angler also. So this is the angler onto which the welding is done. Now this 1-inch rod can be moved up and down so that you can tension the chain as and when needed. This tire that is used is of 8-inch in diameter. A small height adjustable steel is used for making the soil move into the furrow that is created for seeding. Height is again adjusted using this particular long bolt. So using this you can bring it up or down. You are having a double nut, so using the double nut locking is done. Here when the second nut is tightened, it gets locked. And then I am using a small piece of wire that is connected to the framework, so that when if the petrol something pushes, it gives a little bit of angle and then comes back to the initial position rather than getting bent. Now let us create our furrowing tool so that the seeds can be dropped into the holes drilled in the soil. For that we will be using a 1-inch angler, a long bolt, and a small metal pipe around 1.5 inch long, cut in a conical shape. What we will do is we will weld this. First we will cut this 1-inch angler so that we have a pointed edge on one side and a rectangular edge on the other side, and then we will keep this seed dropper here and weld the rod. I'll do that and then show you. Here is the finished part. So this is how it will be. So this part will be digging furrow through the land, and seed will be dropping through this tube, and this will be connected to the machine. For a better seed to soil contact, this particular tire will give the light pressure that is needed. Materials used for the seeding cylinder. This is the main cylinder. This 1 and 1/4-inch PVC pipe. I am having 2 end caps of same measurement. This is mentioned as 40 millimeter, 2 end caps. Then I have a CPVC connector section. This is 1 inch. Then I have a CPVC pipe that I can insert into this 1 inch section, and 2 end caps for the CPVC. So these are the materials that I am using to build the seeding mechanism. Now let us see the design constraints of the seeding mechanism. Redgram needs around 20 cm seed gap, and blackgram needs around 10 cm seed gap. I am using these two examples because most of the time these two are intercropped. Main wheel that is connected to the chain is around 63 cm in circumference. So all our calculations will be based on that particular circumference. The thing is, the calculation that we will be doing is, when the wheel rotates for once, how much distance does the wheel travel? So in that particular distance, how much seeds we should be sowing. So looking here, you are seeing 63 centimeter as the wheel circumference. So for Redgram, for every 20 centimeter we need one seed to fall, and for blackgram we need around for every 10 centimeter one seed should fall. This is the design criteria. So what it means is, for the 63, let us remove the 3 centimeter and make it 60. So for every 20 centimeter, that is when the wheel runs once, you should be having 3 seeds falling. This is considering that this particular wheels that are connected to the chains are in 1:1 ratio. That is, the diameter of this chain is equal, to this sprocket is equal to this particular sprocket. So with that in mind, we will be having 3 seeds dropped for Redgram for every wheel rotation, and we will be having 6 blackgram seeds dropped for every rotation of the wheel. So let us first design for the blackgram seeds. So for blackgram, first you search out the biggest possible seed and smallest possible seed in the batch. Just randomly check for some seeds, you will be getting the biggest one, and then you will be getting the smallest one. So now just measure the biggest one in the longitudinal way. Okay, and then you need to get a drill bit of same size. So this will be the diameter of the hole that you will be drilling into the CPVC pipe. Now one thing you might have already noticed is this wall thickness is bit less. So that is where I will be inserting this 1-inch pipe into, so that now the wall thickness gets doubled. Moreover, it will be easy to put the end cap. I have designed another tool for putting holes into this CPVC, because with machine controlling the speed is very difficult, and you will put a bigger hole than what is needed. So here what I have done is this one GI pipe, into which a small drill chunk is welded. Now into this weld chunk I can put anything that I need, including screwdriver, drill bit, knife, you name it, and you can put it. This is just a handle for any tool that you want to make use of. So I'll putting this particular bit into the chunk, and I'll show you what I'll be doing. Using this drill chunk, I have drilled holes out here. So this is drilled for our black gram. I am having 6 holes out here. 1, 2, 3, 4, 5 and 6 at equal distance. So first you'll have to find the circumference of this whole CPVC, and you'll have to divide it into equal sections. For me it turned out to be around 1.8 centimeter between these two sections. Now you can put the large one and see whether it fits perfectly in the sense it should be slightly loose so that it falls out. Make sure it happens that way. Check in all directions to see whether it is free in the socket. So if it is free, it will drop off. Now the importance of this smaller seed is that most of the time, since there is excess space, they will be fighting each other to get into the socket together like this. So here you are having 2 seeds. So if you design it perfectly, the section that will come above this will be able to wipe off the second seed. The big seed cannot sit there. It will not sit there. So just try it out, and that is why I showed you the larger seed and smaller seed. Now the same principle applies for Redgram as well, and in the same CPVC on the other side you can drill holes for Redgram, this side. Now the next thing is to drill holes into the PVC and the CPVC for the rotational effect to take place. So that is a bit tricky basically, because you are having a oval shape out here on the CPVC as well as PVC. To find the center at home was not that easy for me. You may be having some other ideas, but this is what I did. I used the 1-inch pipe to mark out a paper like this, and then I cut the circle, and in the circle I marked the center, and then I inserted that paper into the CPVC pipe. And here, since now I am getting the center with the PVC getting stuck like this, and then removing so that it stays in properly. Now this center I am just marking it with a marker pen in the hole like this. So to come to this idea I had to try many things, like drawing the flower like this. The problem is it was very difficult for me to get the actual center, but with this it was possible to get the center. Now you can see the center. So how to verify whether it is center? You just keep it and just rotate it. So if the center is not, if it is center, it will not be shaking. If the dot is anywhere else, you will see it going to the other angles. See, so these holes will have to be drilled into the CPVC as well as PVC. Friends, the cylinders are ready. This is the cylinder for seeding, and here you can see I have put center hole on both the sides. So now for Redgram we are having only 3 seeds, so that it disperses seed at a distance of 20 centimeter each. And the way this is done is, you can see the seed will be just able to sit in the hole. It will be just coolly sitting with a small protrusion, so that a second seed cannot be accommodated into that, and it should be loose enough so that the seed should jump off when rolling. And same thing for the black gram. So now what we have to do is, we'll have to insert this cylinder into this one, and use a hopper to fill the seed through this, and cut another hole down so that the seed goes out. So for this I am using a 1 inch to 1.25 or 1 by quarter inch connector. This will be the hopper side. This will be the place where the seeds will be put through. And for the other side I am using a 32 mm to 20 mm reducer. So this is the place where the seeds will be getting dispersed. So as you can see, I have just cut both the reducers to an oval shape so that it fits properly onto the plastic. I'll be using some synthetic adhesive or something like M-Seal, Araldite or something to stick this into the PVC pipes. Now we need to have some stuff to hold all these things onto the steel plate. For that I will be using this sections from this 1.5 inch GA pipe that I have cut into maybe 4 millimeter thickness, so that it will reside out here, and I can clamp it in the way it is done here, using one screw, nut and bolt here, 2 washers and the screw here. So this keeps the whole cylinder tightly onto the machine. Let me complete these things and then I will come back. Now the bolts are welded. Now the next thing is to weld these washers onto the board like this. So that we can put a nut and then adjust the tension. So to do this, what I am doing is, I welded another nut out here and tightened the bolt out here. Now I can easily weld it by keeping the washer out here. So this is a fastener. If it is easier for you to get the fasteners from market, then go for that. Friends, here is the assembled seeding part. So this is how it is put. There are 2 washers on one side, 2 bolts. One is to lock the other bolt. Once tightened, the other bolt will get locked. So on both sides you will be having the same configuration. 2 washers so that there will be no friction, and 1 washer here so that it will be held tightly. And this this nut will be tightened towards the wall of this socket, and this nut will be locking it. Same configuration on the other side also. Now this is the shell cylinder, the outer cylinder, into which we will have to now make the hopper and all. So first we will put it and see whether the sizes are matching. Okay, see, it came out here. So here is the other side also put. Now one thing you should be careful is it should not be loose like this. Once you fit this, it should be perfectly sitting there with maybe a 1 mm of movement, not more than that. A slight movement is okay, but a fast movement is not okay. And then you have to rotate it and see whether it is rotating smoothly, whether there is any friction or anything. If there is a friction, that means your alignment is not correct. You may have to redo it. Now the next thing to consider is plastic to metal contact is actually a weak contact, because as this rod starts rotating, this plastic hole will become bigger. So to circumvent that, we will have to put a rivet there. What I am using is a old batteries outer covering, outer case, the plate that in the battery. I'll be just cutting it on the side and then putting it out here. I'll do that and show you. And this is how it will be, that rivet part. So you have a bit of extending part here. Either you can cut again on the sides and then bend it, or just cut it off. So how to do this? This is a thin sheet of metal. What I will do is I'll keep here and just bend it, roll it over. Just depending on the gap you are having on this plastic, you may have to use just one roll, or maybe you may have to roll it twice. So here is the final product. So you can see the rivets out here. Now it should be smoothly rotating. See, without any friction, it is rotating. So that part is done. Now, as mentioned earlier, we have to cut the holes for seed in and seed out. I'll do that and then show you. So here is a seeder. It's ready for use. You can see the the chain sprocket, the timing chain sprocket. Here I have the belts tied up, and this is the seeding actuator through which the seeds will be put through. See, it's now configured for the background, and here also we are having the belt, and this is the rod protruding out. So now for testing, we'll go to the agricultural field. Okay friends, let us now test it. So here is the machine. Here I have put the seeds. So I'll be just running it and seeing whether the seeds are dropping. So first, let me sow it and then we'll see the germination rate. So this is how they have come up.